Good morning, all of you. In today's class, we'll continue the Newton's second law of motion and as well as what is the units of Newton's second law of motion. And the next one, we'll study what is the applications of Newton's second law of motion. And last, finally, we'll study what is the numericals which is related to this Newton's second law of motion and how to solve them. That is all we'll discuss in the today's class. So let us come to here. First one, as we have discussed in yesterday's, what is Newton's second law? Can you able to say anybody? What is Newton's second law? You have studied. Newton's second law is defined as. What is Newton's second law? Please. What is Newton's second law? Pradosh? Tamil Selvan? What is Newton's second law? What is this? No response. So F is equals to MA. That is what the Newton's second law which we have studied in last class. Correct? Hey, can you able to hear me? Nobody is saying. Only Pradosh is saying what is okay. What happened to others? Laksha? So F is equals to MA which we have studied in the last class. Yelmokil is also joined now. Okay. So now let us come to here. We'll continue from there. Understanding. So what is the unit of Newton's second law of motion and how we need to find it? That is all we'll study. If we'll speak only, it is good, man. If not speaking, what is the use of it? Okay. So now let us come to here. Newton's second law of motion. Understanding. Newton's second law of motion, yesterday we have derived that. So finally we used to conclude that force is equals to mass into acceleration. That's all. Is it yes or no? So this is only we used to call it as Newton's second law of motion. So let us come to the units of Newton's second law of motion. Units of second law of motion. Second law of motion. Can you able to say that what is the unit of motion? Mass. What is the unit of mass? Please tell me. What is the unit of mass? Mass is equals to kilogram. As well as what is the unit of acceleration? Please. What is the unit of acceleration? Acceleration is equals to meter per second square. So that's all. So force is equals to mass into acceleration. So mass, in place of mass I can write kilogram, and in place of acceleration I can write into meter per second square. So that is what force is equals to kilogram meter per second square is the unit of Newton's second law. And as well as we know that what is the unit of force? Force is measured in what? Newtons. Is it yes or no? So that is why I can write Newton's second law of motion. Newton is equals to kilogram meter per second square. So this is the unit of Newton's second law of motion. All of you should note it down. Do you understand? Laksha? Alana?
Yes, sir.
So, the unit of Newton's second law is, understanding, kilogram meter per second square, because the unit of mass is kilogram and the unit of acceleration is meter per second square. So if we multiply them, we used to get kilogram meter per second square. So now from this can I say 1 kilogram, from this can I say 1 Newton is equals to 1 kilogram meter per second square. Is it right or wrong? Elamukil, Tamil Selvan, Darun?
Yes, sir.
1
Yes,
Newton
sir.
is equals to 1 kilogram meter per second square. So wherever suppose I am giving 10 newtons is the question. Suppose in numericals I am giving you 10 newtons. So means in the sense of what I can write? 10 kilogram meter per second square. Is it right or wrong?
Yes, sir.
Because in place of 1 Newton, how I can write 10 newtons? 10 newtons I can write as 10 into 1 Newton. Is it yes or no? And we know
Yes,
that
sir.
1 Newton is equals to what? 1 Newton is equals to, speak here, 1 kilogram meter per second square. So that is why I can write 10 newtons means I can write 10 kilogram meter per second square. Is it yes or no? So
Yes,
this
sir.
is what units of Newton's second law of motion. All of you should note it down, right? Units of Newton's second law of motion, that is kilogram meter per second square. Kilogram meter per second square. Please write it. Laksha, do you understand Laksha? Tamil sir, Dharan?
Yes, sir.
Maunishra. So that
Yes,
is.
sir.
So you may observe here, that is what we have found in yesterday. And as we know that what is the relationship between mass and acceleration? Elamukil? What is the relationship between mass and acceleration? So as we know
They
that
are inversely proportional.
directly proportional to mass, understanding, and as well as acceleration. If it comes to the mass and acceleration, mass is inversely proportional to acceleration, or acceleration is inversely proportional to mass. Is it yes or no?
Yes, sir.
Yes. So that is what we have studied in the last class. So, and if it comes to here, force is equals to mass into acceleration. So I can write it. Force unit is Newton. So I can write 1 Newton is equals to what I can write? Kilogram. 1 kilogram. Speak here. 1 kilogram into 1 meter per second square. Is it yes or no?
Yes, sir.
Meter per second square. So this is what I can write. 1 Newton is equals to 1 kilogram into 1 meter. 1 kilogram into 1 meter per second square. So that is what the thing I should write it. So all of you note it down this one. All of you note it down. 1 Newton is equals to 1 kilogram into 1 meter per second square. Do you understand, Ra? Yes,
Yes, sir.
Now, you may observe here, few times I can say F is positive and few times I can say F is negative. So when I will say F is positive, remember always, if I will say F is equals to positive, remember when the force is acting in the same direction of motion, when force is acting on the same direction of motion, then I will consider F is equals to positive. Do you understanding all of you?
Yes, sir.
Next, if force is acting, understanding, opposite to the direction of motion. What is that? Opposite to the direction of motion. Then what we should call Ra? F is equals to then
Negative.
opposite to the direction of motion. Then I can say F is equals to negative. Do you understanding all of you?
Yes, sir.
Example. Sir, I am not understanding, sir. I want example. So let us go to example. Suppose your car, you are increasing speed. Your car is moving forward. Understand? Your car is moving forward. So by that time, you will press the accelerator. So means in the sense of force is also acting in the same direction and the car direction is also moving in the same direction. Is it yes or no? Force
Yes, sir.
in the same direction, motion also in the same direction. Now, suppose if you want to stop the car, moving car is the example of positive. F is equals to positive in this case. Now, when you want to stop your car, what you will do, Ra? You will apply the accelerator or you will press the brakes. If you want to stop it,
Brakes.
so stop your moving
Brakes.
car. So by that time, car will never go back, but the force is acting backward direction. Is it yes or no? Force is
Yes,
acting
sir.
backward direction, but the motion will be in what? Backward, but the motion will be in forward direction. Is it yes or no?
Yes,
So
sir.
our car will come to rust, so that in this situation, F I will consider as negative. Do you understanding, Ra? So whenever
Yes, sir.
F is positive, or else whenever I'm saying F is negative, is it indicating value or only direction? This sign indicating only value or direction? Only it is indicating only
Direction.
Direction. It's not the minus. There is no negative force will be there. Only minus indicating direction. It is only indicating direction. That is what all of you should remember. Suppose I can say F is equals to 10 newtons means the force is acting plus 10 means it is acting in the same direction of motion. If I will say F is equals to minus 10 newtons, then there is no minus 10, no negative force. Only force is positive. But this minus sign is indicating what? Opposite direction of motion. Do you understanding all of you?
Yes, sir.
Understanding opposite to the direction of motion. Is it okay, all of you?
Yes, sir.
So always in sign convention, remember this negative sign indicating positive or negative indicating only the amount of the direction of force, not the amount of force. That is what you should remember. Is it okay, Laksha?
Sir.
Alana, that is what. Note it down, all of you. A very important thing. Pradosh, are you understand, Pradosh? Okay, carry on now. Clear? Any doubt to ask me, Elamukil? Tamil Selvan?
No, sir.
Next, if you don't have any doubt, note it down, all of you. Next concept which we are going to study is applications of Newton's second law of motion. Applications of Newton's second law of motion. Now, let us comes to here. As we have discussed, I think most of the boys, you like cricket. Is it yes or no?
Yes, sir.
People will like cricket or not. Even girls also. If you don't like it, also no problem. So while you may observe carefully, while you are catching the ball, suppose the ball hits by the batsman, while the ball is reaching to your hands, understand? Will you people will catch like this, or you people will try to catch like this? Your hands will go backwards, or you people like this you will catch. That is what I want to ask. I want to know.
Backwards.
All of you.
Backwards.
So
Backwards.
Ball will go backwards, sir.
The ball is coming forward. Understand? The fast moving cricket ball, whenever it is coming, you may notice it. Understand? We will take our hands while catching the ball. We will take our hands very, understanding, slowly and as well as backwards. Why? Can you able to say? Why we are doing that?
Sir, to reduce the impact of force.
Reduce the impact of what? Momentum, not the force. What is that? You should not use
Momentum.
You should use word called as what? Momentum.
Momentum.
If you will catch here like this, so the fast moving ball will come, understanding, and within a fraction of second, it will become zero. The momentum of the fast moving ball will become zero. Is it yes or no?
Yes, sir.
So that is the reason. By that time, what will happen? Like a karate man, how he is breaking the pile of tiles, fast moving hand, like a blow of hand, within a fraction of second, his hand speed becomes zero. So that large momentum is supplied to the piles of tiles so that they are breaking. So the same way, if I try to catch the ball like this, then maybe the ball even jump away from you. Is it yes or no? You may felt, boys, you may felt while you are
Yes,
catching
sir.
the ball. Correct or not?
Yes, sir.
And also, if you try to catch like this tightly, when the ball is coming, fast moving ball is reaching, we'll try to hold it like this, then fraction of second, the moving ball will comes to rest, so that it will leaves the large momentum to our hands, so that our hands will get injury. Do you understanding, all of you? So to prevent the injury to the hands, understanding, a fast moving cricket ball, which is coming with a large momentum, we will just to reduce the momentum little bit less. So we'll move, understanding, moves back his hands and catching a fast ball. So then what is happening? So when you are moving, it will take little bit time to get zero. Is it yes or no?
Yes, sir.
No, suppose if we'll stop here and if I'll try to move a little bit back. So from here to here, it will take some certain time period. So by that time, some amount of momentum is reduced so that our hands may not get injured that much and we may not feel that much hurt. So that is the main reason while you are catching a cricket ball, we will pass our hands backwards after catching the ball because to reduce the momentum. Understanding, Darun? Tamil Selvan?
Yes, sir.
That is the first application of Understand Newton's second law of motion. So to prevent the injury, or to reduce the effect of momentum, we will use this Newton's second law of motion, because when the distance increases, then what is happening? If the time keep on increasing, because momentum is what? Rate of change of time. Is it yes or no? If rate of change of time, if time keep on increasing, then the effect of momentum will keep on decreasing. Is it understanding or not? Both are
Yes,
inversely
sir.
correct or not? So that is why, due to more time taken to stop the ball, the rate of change of momentum of ball is decreased, and because of that, a small force is exerted on our hands of a player so that our hands do not get hurt. Do you understanding, all of you?
Yes, sir.
Yes. Suppose if I'll stop fastly, if I'll stop suddenly, then what will happen? Our hands, if are keeping stationary, and I will try to hold the ball like this, then a large momentum of the ball will be reduced to zero in a very short period of time. So due to this, the rate of change of momentum of a cricket ball will be very large, and it will exert a large force on our player's hand or our hand, so that the hands will get even hurt. Understand? And it may lead to even few times very forcefully. You can see it will lead to even breaking of fingers also. Few times you can see in the fast movement, if you try to catch, the ball will hit your fingers will become swelling, it will start swelling, and it will be painful also. You may face the problem. Correct or not?
Yes, sir.
All of you. So that is the first application of understanding this one. So let us see now. I will show you the picture also. You may understand very carefully. Sir, why we need to do that means to reduce the momentum by increasing time. Because if the time keep on increasing, what is happening, Ra? Momentum will increases or decreases?
Decreases.
Momentum will
Decreases.
decreases. Others also will speak, that is good. Understand? So in this picture, can you able to see in this picture? Observe here. This is graphics and this is the real images. Is it yes or no? So here you can see, if you catch the ball here, if you stop here itself, then a large momentum of force is applied to your hands, because within a fraction of second, the ball will comes to us. So it will exert, the rate of change of momentum is too much of high. So it will injure our hands. So once you will catch the ball there, you can see from here to you are taking here, your hands are keep on going backward, so that little bit time, the time traveling of the ball is keep on increasing. So by the time, the rate of change of momentum will reduces by increasing time. If you are keeping your hands slowly downwards, like this backwards or downward, then the rate of change of momentum will reduces, so that less force is exerted on our hands. So our hands will never get injured. Do you understanding, all of you?
Yes, sir.
Here you can observe clearly. So the person is catching the ball here, but have you noticed it? Is it he is holding the ball here itself, or it is moving backward? Is it moving backward or not? You can see the
Yes,
position
sir.
of the hands. So it is moving little bit more backward. So means in the sense of by the time consuming is increases. Time keep on increases. Understanding? So that if time increases, what will happen, Ra? Momentum will reduce. Rate of momentum reduces, so that the force exerted also, reduces. Understand, Monesh? So that is the first application of understanding Newton's second law of motion. All of you write it. First application of Newton's second law of motion. Newton's second law of motion in our daily life. First one, catching a cricket ball. Catching a cricket ball. Catching a cricket ball. Catching a cricket ball. First application. Catching a cricket spelling, Ra? Cricket ball. Okay. So that is. So now, right, all of you. A cricket player moves his hands. Backwards. A cricket player moves his hands backwards moves his hands backwards, 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 and catching the fast cricket ball, and catching the fast cricket ball, and catching the fast cricket ball. Do you understanding or not?
Yes, sir.
Fast cricket ball. Why? Why?
To, to reduce the momentum.
Cricket ball because to reduce the rate of change of momentum. Rate of change of momentum. So less force is exerted on our hands of a player. Hands of a player. So can be prevented or reduced from injury. Do you understanding, Ra?
Yes, sir.
That is what. Note it down, all of you. That is the first application. Any doubt, anything, ask me, Darun, Elamukil,
No,
Mamani,
sir.
Pradosh, Laksha, and everybody, Tamil Selvan. This is the first application. Next
No,
second
sir.
application. Have you know the long jump or high jump? High jump or long jump?
Yes, sir.
High jump.
Do you know high jump?
Yes, sir.
High jump or long jump. So where they used to jump usually? Can you able to tell me? Is it they are
Sir,
jumping
in sand.
on road or only in sand? High jump
Sand
or
and
Vaira? What is the use of here? Can you able to say in high jump and long jump? Why they are not jumping on the normal road or any hard surfaces? Why they are jumping on only in the sand? The case of high jump. Please tell me.
the sand is very loose, but soil is not very loose, sir.
That is what is the reason?
Sir, when we jump, the soil easily penetrates, sir.
Huh? So now, let us discuss about this one. Suppose you will see. Suppose you will fall on your bed. Are you feeling any change? If you fall on your bed, are you feeling any change in your body? Bed.
No, sir.
No, because it is very, very cushion. Cushion in the sense of very soft. It is contains so much of like a cotton or something, or else in the same way sand. If you fall on tar road, if you fall on sand, where you are feeling the more effect?
Sir, in road.
Road, because road is very, very hard. Is it yes or no?
Yes, sir.
Yes. Now you see, observe, during athletic meet, if you take any kind of high jump or long jump or whatever it is provided either a cushion in the sense of a soft bed, understanding, or else a heap of sand, means in the sense of like a large, huge amount of sand is poured, in that only the people used to jump. Is it yes or no? A heap
Yes,
of
sir.
sand and the ground to fall upon. Is it yes, sir? So the person will jump and they will fall on the sand. Why? Because to prevent the injury at the athletes when he fall down after making a high jump or long jump. Is it yes or no?
Yes, sir.
If he is not provided with this kind of cushion, others also, if not provided with this heap of sand means like a small mountain, understanding, huge amount of sand collected together, heap of sand, then what is happening means when he jumps, when a high jumper, understanding, or else a long jumper, when he jumps and falls on a soft landing site, like this cushion or a heap of sand, the jumper takes long time to come to a stop. Means he will slide like this. Have you noticed it? When he is jumping, he will keep the legs forward and he will fall down. Have you noticed it or not?
Yes, sir.
All of you. Now, what is happening? The rate of change of momentum of athlete is less, due to which a smaller stopping force acting on the athlete. Because he's taking a little bit time to stop. He's sliding on the sand, or else he's sliding on the cushion. So the cushion is having enough soft, or else the sand is being soft. It will reduces the athlete's momentum more smoothly or more gently, so that he will never affected with any kind of understanding injury, even though he is falling from certain height. Understand? So because when he is moving little bit more distance in the sliding in this cushion or sand, so that momentum will be reduced to zero in a understanding long period of time, not short period of time, so that no injury. Suppose if he jumping on the hard ground, what will happen, Pradosh? If he jumping on the hard ground, what will happen? Hard ground, within a fraction of second, within a very short period of time, he will come to the rust. Is it yes or no?
Yes, sir.
Short period of time he will come to rust. Is it yes or no, Ra? So that what will
Yes,
happen?
sir.
A large momentum will be produced, so that it will lead to the injury or not. Yes or no? So you can
Yes,
observe.
sir.
Yeah, he jumping in the sand, so that the momentum, the less momentum will be exerted on his body, because he will try to slide. See, you can see when you will fall here. Always you may observe long jump. The person will never sit, try to jump, never jump like this. He will try to keep his legs forward, and he will try to move like this. Have you noticed it or not? He will try to slide like this. Because, understanding, if you will jump in a constant place, single place, then or else any kind of hard surface, what will happen? The understanding, the large momentum, the rate of change of momentum is very large, and within a very short period of time, understanding, the momentum will come to rest. Short period of time, momentum becomes zero, means in the sense of it will be supplied to our body, so that it will leads to the injury. So that is why we can provide any kind of cushions. Cushion means like a soft pillows. Understanding? Cushion are heap of sand means in the sense of, so the person can travel little bit, he will slide little bit, move forward, so that what is happening, the momentum will reduces in a long period of time. It will take little bit long period. Understanding? Time is increasing, long period of time to come to rest. So that what is happening, by that time momentum will become zero slowly. Momentum becomes zero. Understanding? Slowly. So what is happening, Laksha? So that what is happening? The injury will be reduced. Injury will be reduced, or else it is prevented. Is it yes or no, Pradosh?
Yes, sir.
So that is the second application in case of understanding, in case of high jump and as well as long jump. All of you write it. In case of high jump and long jump, in case of a high jump or a long jump, right? During athletic meet, all of you write. During athletic meet, a high jumping athlete is provided an athletic meet. A high jumping athlete is provided either a cushion or a heap of sand, on the ground to fall upon, provided heap of sand or cushion provided on the ground. Why, because what is the reason, Nilamukil? Because to
Reduce the injury.
to reduce the effect of momentum to reduce the effect of momentum by increasing time period. Is it yes or no?
Yes, sir.
Increasing time period. So that what will happen? So momentum will become zero a very long period of time. So that is why it can prevent from what?
Injury.
It can prevent from injuries. That is. So this is the second application. Do you understanding all of you?
Yes, sir.
Say yes or no. Others?
Yes, sir.
Sir.
Now, let us go for third application. Do you have cars? Everybody, do you have cars? I think most of you people are having car. Correct? I think nobody
Yes, sir.
don't have a car.
Yes, sir.
Yeah, everybody is having car. Whenever you enter into the car, what is the first step in our car before going to start or else before going to move? What is our first step in our car? What is how to do when you are trying to drive a car? Something should be wear. Your father or mother will wear immediately something. What is that? Can you able to say?
Seat belt. Seat
Everybody,
belt.
Change the gear.
gear.
Seat belt.
Gear if will change, you will go and will police will catch you and they will fine. And if you will hit an accident, then definitely you will come out from the glass. Have you noticed it? Some movies and all you may watch. If an accident will happen, the driver will come out from the front glass. Is it yes or no?
Yes, sir.
Yes. So what is the reason behind it? What is
Sir,
the
do not wear a seat belt.
So in this situation you observe in this picture you may observe carefully here. The driver is the person who is sitting in the driver's seat came out from the window when he met an accident. When he met an accident, understanding. So he came outside from the understanding window, like in the sense of, and you can see back persons are also hitting front seats and the front persons are coming outside. Have you noticed it in this picture?
Yes, sir.
Observe carefully, all of you. So why it is happening? Even nowadays the cars, even back seat is also providing seat belt. Is it yes or no?
Yes, sir.
So what is the reason behind it? Can you able to say? This is also Newton's second law of motion only. Can you able to say why it is? You may observe carefully here. If the person here see, if you have met an accident, if you are wearing the seat belt, understand, then you people will never move forward direction. Understand? And you will never, even though if even huge accident will happen also, you will never come out like this out from the glasses and all, because they will reduce the understanding momentum. And you may notice it, our police instructions and all, there is a traffic rules, wear the seat belt, save your life, like that they will say. If you are traveling on bike, wear the helmet and save your life, like that they will say or not?
Yes, sir.
Yes. So most of the cases, if you wear the seat belt, then definitely understanding you can be prevented from the death situation. So what is happening? That is what the third applications of it. The use of seat belts in cars. Write it. The use of seat belts in cars. All of you. The use of seat belts. The use of seat belts in car. What is happening? Manish, you have a car, correct? Everybody is having car. So what is the use of seat belt in car? Please tell me. What is the use of seat belt in car? So it will prevent the injuries in case of an accident. Is it yes or no? In case of
Yes, sir.
accident, it is preventing from the death situation. It will prevent the injuries in the case of accident. So what is happening here, you see? Suppose when the car will stop suddenly, what is happening? A large momentum reduces to zero in a very short period of time. Is it yes or no?
Yes, sir.
Yes or no? Suddenly, if you stop the car, what is happening? We people will hit the steering. Is it yes or no? Have you noticed it? People will hit the steering, or else back seaters will come and will fall down forward. Is it yes? Because within a fraction of second, the large momentum will become zero, so that it will rate of change of momentum is too much of high, so it will cause large amount of force is exerted, so that it will leads to the even death situation, or else a huge amount of injuries, worst injuries also. So now what is happening here? Understand? So if you are not wearing the seat belt, understand? Suppose even if you are hitting a very little bit more bigger object or something, big accident, then few times even you can come out from the windows. You may notice it in highways and all. Somewhere the accidents will happen where The driver is neglecting to wear the seat belt. So that is why you can see the slightly stretchable seat belts. You can see the stretchable seat belt. It is stretching. You can press like this. You can pull like this and you can push it. Is it yes or no?
Yes, sir.
So the slightly stretchable seat belts if you own, understanding by all the passengers as well as driver, then it will take little bit time to taken by the passengers to fall forward, because it will reduce the time. It will increases the time. Suppose you see, if there is no seat belt, in the case of if there is no seat belt, whenever you will hit no seat belt, what will happen? Whenever the car will comes to rust, immediately the large force is acting on you. You people will fall forward direction. So even you will come out from the window. Understand? But if you wear the seat belt is a structured, structured like rope which we are wearing. So the person is sitting here. So the seat belt is like this. So what is happening? It will increases the time to move forward. So it will increase the seat belts will increases the time, to move forward, whom our body, so that by the time the rate of change of momentum will be reduces, so less force is acting on our body, so that we can escape from what?
Accidents.
Escape from injuries or penalty. That is what is called. Write it. So this is the third application. The use of seat belts in cars. Understanding, Pradosh, Mavanesh, everybody?
Yes, sir.
Write it. So due to longer time, the rate of change of momentum of passengers is reduced, and hence less stopping force acting on them. So the passengers may either not get injured or they may be less injuries they may get, or else even completely may not also get. So that is why you may see that now latest cars, whatever you will purchase, they have back seaters also having a seat belts, and as well as back seaters also having a air balloon. Do you know air balloon? How many of you know air balloon?
Yes, sir.
Metal accidents, it will come and will oppose you. Is it yes or no? It will blast.
Yes, sir.
So now latest cars, minimum seat belts also 4, as well as airbags also 4. Do you understand? Before, if you go 5 years, 6 years, only driver is having a seat belt, and as well as driver next side also having front seats having seat belt, and only 2 airbags is present. But now they are providing 4 airbags. Why? Even to prevent more, less, to reduce the injuries to 0, to reduce the death to 0. They are doing that, because if back also, why they are providing means, if they will met an accident, maybe front 2 persons may not hit, but back person will come forward, as I have shown you in the picture. Do you understanding? Those who are sitting in backward also, they are coming forward. Is it yes or no?
Yes, sir.
For example, have you watched Journey movie in Tamil? Journey. Have you watched that movie? Bus accidents, right? 2 bus will hit.
Yes, sir.
What is the Tamil? Journey 1.
Sir, எங்கேயும் எப்போதும்.
Okay, the 2 bus will accident. The 2 bus will met an accident. Have you noticed it? Even the back sitters, those who are sitting in back sitters also, they will come and will fall forward. Have you noticed it or not?
Yes, sir.
Main thing in that scene, you may observe very carefully. One person will fall. He will come out from the bus and he will fall between the 2 buses and he will crush. Have you noticed it?
Yes, sir.
The person who is standing at the front of the bus. So whenever he will hit, so the person, because of large momentum, within a fraction of second, he is not sitting and he is not wearing any kind of seat belt, because he is standing. So that he will come out from the window. You may observe come out from the front glass, and he felt in between the glass surfaces. That is the worst scene which we are observing. Correct? Yes or no?
Yes, sir.
That is what is happening. So do you want to see that? You want to watch that scene? Pranita? Okay. That is what is happening.